Time is way stranger than clocks. Your morning alarm is already lying to you. The sky above you is a time machine. Your phone survives on tiny bits of Einstein. Even your own body is keeping unequal time. The wild part is that none of this is science fiction. It is physics. And it is happening right now. By the end, your ordinary Tuesday will look a lot less ordinary. Seconds will feel suspicious. Days will feel wobbly. And the last fact is probably in your pocket. At number 12, every sunrise you see is already old news because sunlight needs about 8 minutes and 20 seconds to arrive. The sun sits about 93 million miles away, close in cosmic terms, but still far enough to delay the show. So when light warms your face, you are not seeing the sun exactly now. You are seeing the sun as it was a little over 8 minutes ago. That sounds small, until you realize every glance at the sky is technically a peek into the past. Astronomy starts with this simple trick. Light has a speed limit, and distance turns that limit into memory. You are basically living under a constant broadcast that is always a little delayed. And once you notice that, the next fact gets much bigger. Telescopes do not just magnify space, they rewind it. Hubble collects light that has traveled for years, centuries, even billions of years before finally reaching its mirror. Look at Proxima Centauri, and you see a star roughly 4 years younger than the moment you're standing in. Look at Betelgeuse, and you see it about 700 years in the past. Hubble has even observed galaxies as they appeared more than 13 billion years ago. That means some objects we can still see may have already changed dramatically or even vanished long ago. The deeper space gets, the more astronomy starts to feel like archaeology with starlight instead of shovels. And somehow, time gets weirder when humans try to organize it. For a long time, towns use their own local solar time. Since the sun appears to shift by longitude, local time changes about 4 minutes for every degree eastward. Before standardization, that meant nearby towns could disagree by minutes, just because they sat at different longitudes. That became a mess once railroads started running tight schedules across huge distances. So US and Canadian railroads adopted standard time zones in 1883. Without that change, travel timetables would have been a rolling comedy of missed connections and clock arguments. A year later, Greenwich was chosen as the prime meridian, helping shape the modern global time system. And yes, humans solved chaos by slicing the planet into time-flavored wedges. Then we added one more twist, a line where the calendar itself flips. Near 180 degrees longitude sits the international date line, zigzagging to respect borders and waters. Cross it westward and you add a calendar day. Cross it eastward and you drop one. So two places can witness the same moment while living on different dates. It is one of the few places on Earth where moving forward can make your calendar jump backward. Time zones already feel strange, but a line that edits the day is wonderfully ridiculous. And that still is not why February keeps acting weird. Earth does not orbit the sun in a neat 365 days. One trip around the sun takes about 365.2422 days. That leftover fraction keeps piling up, so calendars would drift without occasional repairs. Leap day is the patch, an extra February day roughly every 4 years. Without that patch, seasons and calendar dates would slowly drift apart. But even that fix is slightly too generous. So century years skip leap day unless they are divisible by 400, which is why 2000 counted and 2100 will not. If calendars need maintenance, wait until you hear what happens to the second. Leap seconds exist because Earth is a terrible metronome. Atomic clocks keep beautifully steady time, but Earth's rotation is irregular and gradually slowing overall. To keep official time aligned with astronomical time, an extra second is added when needed. The goal is to keep UTC within 0.9 seconds of UT1, the time based on Earth's rotation. That means one rare minute can contain 61 seconds instead of 60. These adjustments are rare, but software, networks, and timing systems absolutely notice when they happen. We literally pause the world's clockwork, so noon does not wander too far from the sky. And that only happens because a day is less stable than it looks. A day feels fixed, but Earth's spin is constantly being nudged around. The moon's gravity tugs our oceans and slowly breaks the planet through tidal friction. The atmosphere shifts, water moves, the liquid core swirls, and even earthquakes can tweak rotation a little. Even melting ice and giant water projects can nudge the planet's spin in opposite directions. Over very long stretches, Earth's mean solar day increases by about 1.6 milliseconds per century. That sounds microscopic, but tiny changes in rotation add up over decades and centuries. So the 24-hour day is more of a useful average than a perfectly rigid promise. Now let's shrink from planetary wobble down to the second in your watch. Your second is not based on Earth's spin anymore. Since 1967, the official second has been tied to the cesium-133 atom. More specifically, 1 second equals 9,192,631,077 siebels of a particular cesium microwave transition. That absurdly specific number came from matching atomic behavior to earlier astronomical definitions of time. That is how official time stopped depending on a wobbling planet and started depending on quantum behavior. The brilliant part is that atoms do not care about weather, tides, or whether humans overslept. So atomic time gave us a steady heartbeat while the rotating Earth kept being gloriously unreliable. And modern clocks took that idea to a level that sounds made up. Some of today's best clocks are so precise they barely feel real. NIST says its lattice clocks would not have gained or lost a second since the Big Bang. That's roughly 13.8 billion years of staying on beat. These clocks are so sensitive they can detect tiny differences caused by changes in height and gravity. At that level, measuring time and measuring gravity start to blur into the same strange science. In other words, timekeeping has become precise enough to measure the shape of reality itself. We built clocks so good they started tattling on the universe, which is exactly how scientists caught one of Einstein's strangest predictions in everyday life. At higher elevation, time moves slightly faster. NIST tested this by raising one ultra-precise clock, just about a foot above another. The higher clock ran a little faster, exactly as Einstein's general relativity predicted. So yes, your head is technically older than your feet. The difference across a lifetime is tiny, about 90 billionths of a second over 79 years. A staircase is enough to reveal it, which still sounds like physics showing off. You will not feel it, celebrate it, or get an extra birthday cake from it. But it means gravity is quietly editing time inside your own body. Motion edits time too. According to relativity, the faster you travel, the slower you experience time compared with someone moving less. Scientists even flew synchronized clocks on airplanes and found the airborne clock ended up slightly behind the ground one. NASA explains the same principle with satellites and spacecraft racing around Earth. The effect is tiny at ordinary speeds, but experiments have shown it is real and measurable. This is real-time travel to the future, just not the movie version. You do not jump ahead dramatically, but you do age a little less while moving fast. And that brings us to the fact, hiding inside almost every commute. GPS works only because engineers treat time as bendable. Satellites move fast enough for speed-based time dilation, and they orbit high enough for weaker gravity to speed their clocks up. Those two effects do not cancel perfectly. The clocks in orbit end up running at a different rate than clocks on Earth. So the system must correct for relativity, including velocity, gravity, and even Earth's rotation. Ignore those corrections and location errors would build into miles each day. Your map would slowly drift away from reality, which is not what you want during a left turn. Which means your phone can find coffee, buses, and your friend's apartment because space literally changes time. That is the part of this list I cannot get over. The universe handed us a weird rule, and humans turned it into directions to the nearest pizza place. If that melted your brain a little, good. There's a whole universe of facts hiding inside things you use without thinking. If you want more everyday stuff that turns secretly cosmic, there is plenty more waiting after this one. And if one of these facts rewired your sense of normal time, send it to the friend who is always late. Because the next time a clock ticks, it will sound less like routine. it will sound like reality doing something wonderfully weird in plain sight.